We thought we understood the universe. That the expansion of space, the birth of galaxies, the ticking clock of cosmic time, all of it, was a done deal. A solved puzzle. We had equations, models, even Nobel Prizes to show for it. We thought we had tamed the chaos of the cosmos into neat, elegant math. But now, everything is falling apart. Not in theory, not in speculation, but in the hard, measured data from the most advanced telescopes ever built by human hands. And what they've revealed isn't just a wrinkle in our models. It's a fracture. A fault line running straight through the bedrock of modern cosmology. The universe, it turns out, doesn't behave the way we believed. Not even close. At the heart of this disruption lies an ambitious scientific experiment. The goal: combine the visible light legacy of the Hubble Space Telescope with the unprecedented infrared reach of the James Webb Space Telescope. Together, they would peer deeper into space, and therefore further back in time, than any instrument had ever done before. With Hubble's proven eye for distant galactic structures, and James Webb's power to cut through cosmic dust and see the invisible, astronomers believed they could unlock a clearer picture of the early universe. What they hoped to find were the first galaxies, glowing faintly from the edge of time, slowly assembling in the quiet aftermath of the Big Bang. But what they found instead broke the model. It began with a single galaxy. Catalogued as ZFGS 7329, it seemed at first glance to be just another distant object. But when astronomers calculated its age and size, their jaws dropped. This galaxy wasn't just old, it was impossibly old. So massive, so luminous, so complex, that it had no right to exist in the early universe. According to every model of cosmic evolution, there simply wasn't enough time for such a colossal structure to form. Not enough time for the stars to ignite, for dust to gather, for gravity to sculpt such beauty from chaos. This galaxy alone contradicted the very timeline we've trusted for decades. But it didn't stop there. Soon, more galaxies were discovered. Not one. Not two. Dozens. All ancient. All massive. All in direct conflict with the standard model of cosmology. Then came the black holes, monsters at the hearts of these galaxies, far too large for their age. In our models, supermassive black holes are the product of billions of years of slow accretion. But these objects were fully formed, ravenous, and powerful at a time when the universe should still have been assembling its first stars. And then came the most chilling revelation of all: the expansion of the universe, the very heartbeat of cosmic time, is inconsistent. We used to think it was a simple number. The Hubble constant. A fixed rate at which galaxies drift apart over time, like dots on the surface of an inflating balloon. But now, with Hubble and Webb working in tandem, scientists have found that the rate of expansion changes depending on where you look. The numbers don't agree. And not by a little. By a lot. For years, astronomers have relied on Cepheid variable stars, those brilliant, pulsing beacons scattered across distant galaxies, as standard candles to measure the scale of the universe. Using their predictable brightness patterns, Hubble established a Hubble constant of about 73 km per second per megaparsec. But when James Webb performed the same measurements on even deeper and older galactic structures, the results came back drastically lower. This isn't just a rounding error. It's a cosmic contradiction. A signal that something fundamental, something terrifying, is wrong. Adam Rees, the Nobel Prize-winning astrophysicist who helped lead this research, put it bluntly. If measurement errors are ruled out, the only explanation left is that we fundamentally misunderstood the universe. And that quote has sent ripples through the halls of theoretical physics like a thunderclap. What we're witnessing is not just a scientific debate. It's a full-blown crisis. A collapse of our most sacred assumptions. The age of the universe, the nature of spacetime, the composition of reality itself. Everything is now up for renegotiation. And into this storm of doubt stepped Rajendra Gupta, a theoretical physicist with a stunning proposal. What if we've been wrong not just about the expansion of the universe, but about its very age? According to Gupta, the cosmos isn't 13.7 billion years old as we've long believed. It's closer to 26.7 billion. Twice as ancient. Twice as strange. His theory? That what we see as redshift, the stretching of light over cosmic distances, doesn't just happen because of expansion. It happens because the very nature of light is misunderstood. He argues that photons, particles of light, lose more than energy over time. They lose information. He proposes a model in which space itself is more complex, more dynamic, and more deceptive than we've realized. In this model, the need for dark matter and dark energy, the two invisible forces that supposedly make up over 95% of the universe, is eliminated entirely. They're not real, Gupta suggests. They're ghosts we invented to fix broken equations. What's real is more subtle, more intricate, and far more unsettling. If Gupta is right, our understanding of the vacuum, the empty fabric of space, is fundamentally flawed. That would mean that Einstein's general relativity, the quantum fields we rely on to explain particles and forces, even the nature of time itself, all need rewriting. And yet, some physicists are going even further. They're asking the question that few dare to speak aloud. What if our universe isn't alone? What if the contradictions, the inconsistencies, the broken laws of physics at the furthest edges of space, are being caused by something outside of it? According to a growing number of theoretical models, our observable universe might be just a bubble, one of many, in a vast cosmic foam of parallel realities. And now, based on the latest data from Hubble and Webb, some scientists believe they have found mathematical signs of interference. Imagine, they suggest, that a neighboring universe, invisible to us yet close in a higher dimension, is exerting gravitational force on our own. That pull, subtle but constant, could explain why space is expanding faster in some directions than others. It could explain the asymmetries, the inconsistencies, the strange drift of galactic clusters. And if that's true, then the laws of physics as we know them are not universal. They are local, temporary, fragile. This isn't science fiction. It's peer-reviewed, data-driven, mathematically modeled science. And the implications are nothing short of existential. Because if our universe is being influenced by another, it means we are not just small. We are not just alone in a vast emptiness. We are one node in a cosmic network of realities, all pushing, pulling, shaping one another in ways we are only beginning to glimpse. The universe is not a sealed box. It is a porous, bleeding edge of something far larger than we can see or comprehend. And the deeper we look with our most powerful tools, the more that box seems to warp and crumble at the edges. At the furthest boundaries of observation, where Webb's golden mirrors catch photons that have traveled billions of years, the cosmos itself appears to be glitching. Time behaves oddly. Galaxies form too quickly. Black holes grow too fast. Light bends in ways no equation can explain. It's as if the universe is trying to whisper its secrets to us, but we no longer speak the same language. So where does that leave us? At the edge of a paradigm shift. A moment like no other in modern astronomy. A time when every equation is questioned, every constant challenged, every assumption placed under a microscope. And while it may feel like a crisis, it is also a kind of rebirth. Because science doesn't grow in certainty. It grows in the dark, in the unknown, in the questions we never thought we'd have to ask. The universe is changing. Or maybe it's always been different, and we are only now beginning to see it clearly. Not through a telescope but through the cracks in our understanding. What lies beyond those cracks might not just change astronomy. Could change everything. For years, dark energy stood like a towering pillar in our model of the cosmos. A mysterious, invisible force thought to be pushing galaxies apart faster and faster as the universe aged. It wasn't fully understood, but it was accepted, cemented into the lambda CDM model as the dominant component of the cosmos. 70% of everything, we were told, was dark energy, this unknown pressure stretching space itself. It was the elegant fix to explain the accelerating expansion we observed in distant supernovae. A placeholder for what we couldn't yet see. But now, under the unforgiving light of the James Webb Space Telescope, that explanation is collapsing. Because Webb has shown us something no one was prepared to believe. The expansion of space isn't uniform. It isn't neat. It isn't constant. In fact, it appears to vary depending on where and when you look. In one region of deep space, galaxies seem to be flying apart with tremendous speed. In another, the pace slows. Some ancient galaxies appear far too organized, far too luminous, far too soon. If the rules of cosmic expansion aren't universal, then dark energy, our 70% solution, may not be real at all. And if it vanishes, so does the identity of the known universe. This isn't a minor correction. It's not a tweak to the model. It's a catastrophic failure of the very framework we built to describe reality. Imagine removing a beam from a skyscraper and realizing the entire structure sways in the wind. That's where cosmology finds itself now. With each new Webb image, each spectral fingerprint, each recalculated redshift, it becomes harder to defend the old view of a clean, orderly expansion driven by a constant invisible force. And in the face of this unraveling, something strange has happened. Something telling. The public announcements have slowed. NASA, ESA, and other major space agencies have adopted an almost eerie silence. No bold proclamations. No sweeping revisions. Just cautious phrases like early anomalies, unexpected patterns, and complex data. Behind the scenes, however, the story is different. Leaks from internal briefings and international cosmology councils suggest the mood is one of growing alarm. One classified memo reportedly called the situation a paradigm destabilization point, a moment when our entire mental map of the cosmos begins to break. Why the secrecy? Because to admit the full implications publicly would trigger a chain reaction far beyond the scientific community. If the universe no longer behaves as expected, the fallout wouldn't stop with astrophysics. It would ripple into the foundations of technology, philosophy, theology, and even geopolitics. What happens to our confidence in fundamental science when the most precise instruments ever made tell us we've been profoundly wrong? Some researchers, operating outside of official channels, are already speaking more openly. Their ideas are bold, strange, and deeply unsettling. One of the most provocative theories now emerging suggests that the anomalies we're seeing may not be about space at all, they may be about time. What if time isn't flowing uniformly across the cosmos? According to this hypothesis, different regions of the universe may be experiencing time at different rates. It's not just about gravitational time dilation near massive objects, something Einstein predicted and we've measured. This goes further. It proposes that in certain cosmic zones, time itself may have stretched or compressed due to variations in the density of matter, quantum vacuum fluctuations, or even interactions with higher dimensional physics we don't yet understand. It could explain why some galaxies appear older than they should be, because they're living by a different cosmic clock. A clock not in sync with ours. If true, it breaks the very notion of a universal timeline. The Big Bang wouldn't be a single moment of birth but a complex, multi-threaded event. A ripple through something much larger. Something multidimensional. And we, our solar system, our galaxy, could be riding just one small wave of that ripple, unaware of others moving in directions and speeds that defy our comprehension. The result is a universe with no consistent past and no predictable future. A cosmos where history is regional. Where cause and effect may not mean the same thing in every corner. Where light from another part of space isn't just ancient, it's from a place where the rules of time itself were different. And as disorienting as that idea may be, another theory now gaining traction pushes the envelope even further. It's called the cosmic phase transition model. In the simplest terms, it suggests that the laws of physics themselves may not be permanent. That like water freezing into ice or boiling into steam, the universe could undergo phase transitions. Shifts in its fundamental state. Changes not just in temperature or energy levels, but in the actual rules that govern reality. According to this model, the strange data coming from James Webb and Hubble aren't signs of chaos. They're early warnings. Signals that our universe may be approaching a transition. An epochal moment where the underlying constants, like the speed of light, the strength of gravity, or the charge of an electron, could abruptly change. These aren't glitches. They're precursors. And if such a transition happens, whether in 1,000 years or in the next 10 seconds, it would be like flipping a cosmic switch. The universe would reboot. Reality would rewrite itself. Physics as we know it would vanish, and a new set of laws would emerge as alien to us as ours would be to a fish trying to understand fire. Imagine a universe where gravity repels instead of attracts. Where time flows in spirals, not straight lines. Where particles we haven't yet imagined take center stage and everything familiar, atoms, molecules, stars, cease to exist in their current form. To some, this sounds like apocalypse. To others, evolution. A natural cycle on a scale far beyond the lifespans of stars. A rebirth of reality itself. And perhaps this has happened before. Perhaps the reason we struggle to understand the origin of the universe is because it wasn't the first. Just the latest in a series of cosmic reboots. Each leaving faint scars in the fabric of space, each contributing to the anomalies we now observe. What's most astonishing is that none of this is speculation anymore. These theories are being fueled by actual data. Numbers, measurements, spectral lines. Photons collected over billions of years, now being read like ancient scrolls by the most powerful instruments in human history. We didn't invent these mysteries. We revealed them. And that's the deepest irony of all. For over a century we believed we were mastering the universe, measuring its expansion, charting its beginning, writing its laws into textbooks. But now the James Webb Space Telescope has exposed a darker truth. We weren't discovering the universe, we were only seeing what it allowed us to see. A shadow play behind a veil. An illusion maintained by limited tools and hopeful assumptions. Now that veil is falling. The constants are no longer constant. The laws are no longer law. Time itself may no longer be marching forward in unison. And the space between galaxies, once thought to be empty, now appears charged with purpose. It may not be a vacuum at all, but a dynamic, churning field of unknown forces. What we once called dark energy may be nothing. What we called background radiation may be a signal, a message, or a memory. Something left behind by a previous universe, or something trying to reach into ours from beyond. And most terrifying of all, the expansion of the universe may not be random. It may be directional, intentional, the product of an unseen influence, a force we haven't yet dared to name. We are no longer asking how the universe began. That question seems too simple now, too narrow. Instead, we are asking if it is still beginning, or if it is already ending. Or worse, if the very idea of a beginning and an end is a human illusion. A comfort we invented in the face of something we can't control. This is the edge of knowledge. The place where science meets philosophy, where equations give way to awe. We are standing at the edge of a map, looking out over a terrain no one has ever seen. And as terrifying as that is, it is also exhilarating. Because it means the story of the universe isn't over. It's just beginning a new chapter. One that no one, not even the best minds on Earth, can predict. So the question now is, what happens next? Will the laws of physics hold? Will we witness a shift in our cosmic environment? Will time splinter, reality bend, or something far more miraculous unfold? The James Webb Space Telescope has opened the door. What lies beyond it may redefine everything. And we must be ready, not just to observe but to imagine. To ask the questions we were once too afraid to ask. To let go of what we thought we knew. Because if the universe is rewriting itself, we have just read the first line of a new reality.